Alright class, so the last couple of lectures we've been talking about redox. Now this lecture, what I'm going to do, I'm going to slow things down. I'm not going to introduce any new material. We're just going to do some practice problem with redox and also go over all the concepts to make sure that you have this redox down. Alright, so one of the things that I want to go over, because I know some of you guys are having a problem with, is oxidation number. Well, first of all, before I do that, again, remember, when you have a redox is oxidation and reduction. Oxidation, loss of electron, you become more positive, you're a reducing agent. Reduction, gain of electron, you become more negative, you're an oxidizing agent. But before we can figure out what's been oxidized and what's been reduced, we need to assign oxidation number. So assigning oxidation number will help us figure out which one is being oxidized and which one is being reduced. Now, when you assign oxidation number, there are three things to kind of remember. The first one is anything in its elemental form has an oxidation of 0. If that's how they exist in nature, in an elemental form, they have an oxidation number, oxidation state of 0. For example, silver metal, right? Silver metal, that's how it exists in nature. Silver metal, that's its elemental form. So the oxidation number would be 0. Copper metal, right? Copper solid, copper metal, copper, that's how they would exist in nature. It's an elemental form. That would be oxidation number of 0. We also said diatomic molecule, that's how they exist in nature. That's their elemental form. When we say I'm breathing in hydrogen gas, we don't mean H, we mean H2. When you say I'm breathing in some oxygen gas, it means O2, not just O, right? That's how they exist in nature. That's their elemental form. So the oxidation number is 0. So that's one thing to think about. Elemental form, the oxidation number is 0. Now, when you have an ionic compound, remember what an ionic compound is. You lose or you gain electron. So if you lose or you gain electron, so the oxidation number is the same as charges, because ionic compound is a balance of charges. You lose and you gain electron. So you can figure out the oxidation number based on the charges. Now, here I have Ag2S, okay? So let's go over what would be the oxidation number of Ag, and let me 1 second. What would be the oxidation number of Ag, and what would be the oxidation number of sulfur? Okay. Now again, is this an ionic compound? Yeah, because I have a metal and I have a non-metal. Go back to the basics. Always go back to the basic. You have a metal and a non-metal, so I'm an ionic compound. Again, ionic compound, the metal is going to lose electron, the non-metal is going to gain electron. Is a transfer of electron, right? Is a balance of electron. So what is the oxidation number of Ag? The charge of Ag is plus 1. The charge of sulfur is minus 2. So the charges is the same as oxidation number. Because the sulfur was minus 2 and the Ag is plus 1, that's how you balance the charges. Okay, so the oxidation number is same as charges. Every time you see an ionic compound, you know the charges, that will be the same thing as oxidation number or oxidation state. Beautiful. Now, what if you have a covalent compound? Again, think about what's a covalent compound. When you have two non-metals together, that's when you have a covalent compound. So you have a metal and non-metal together, ionic compound, you know what to do. You see two non-metals together, you go, okay, this is a covalent compound. Now, covalent compound, because it's two non-metal, there are no charges. There is no balancing of charges for covalent compound. So we can't just say the charges is the same thing as the oxidation number. We have to use the rules that I've given you. And the rules were hydrogen is always plus 1, oxygen minus 2, fluorine minus 1, 1A group plus 1, 2A group plus 2. You equal the sum to 0 or to the ionic charge, and then you figure out the oxidation number. Okay. Now, ready to do one here together? So CO2. Do you agree CO2 is a covalent compound? Is a covalent compound because what I have two non-metals together. Now, what I want to figure out what's the oxidation number for carbon and what is the oxidation number for oxygen. Now, remember what we talked about. The oxidation number for oxygen will always be minus 2. That doesn't change. So is really the carbon that I need to figure out, because we said oxygen is always minus 2. Now, this is a covalent compound, so I have to use this rule. So what I'm going to do, the entire thing equals 0 because I give you no charge. This is a neutral compound. This charge would be 0. If I had given you a charge here, then sure, it would equal that charge. But I don't give you a charge. This is a neutral compound. It would be equal to 0. Okay? Oxygen is always minus 2. Minus 2 times 2 is minus 4. So I can solve for carbon. Carbon would be plus 4. Carbon would be plus 4. So for covalent compound, we can figure it out based on the rules right here. So think about it. Elemental form, 0, ionic, same as charged, covalent. You have to do the rules. Once you do that, then you figure out has it been more positive or become more negative, and then you go from there. So far, so good. All right. Ready to do our first practice problem? Let's do our first practice problem. Here's the practice problem. I have zinc metal plus HCl going to zinc chloride plus H2. First of all, what type of reaction is this? Of course, it's a redox reaction, right? But redox is a big umbrella. If I want to narrow it down more, this is a single replacement reaction, right? It's a single replacement. You have one guy and you have a couple. The single guy breaks up the couple. This is a single replacement reaction. Now, when you have a single replacement reaction, the metal and the cation are going to exchange, right? These are going to exchange. Single replacement reaction. Beautiful. So, what I want you to figure out, I want you to pause this video and then figure out what has been oxidized and what has been reduced, what's the oxidizing agent and what's a reducing agent, okay? Now, before you do that, I can also, balance this equation. So, it's balanced. I put a 2 over here. All right. So, hopefully, if you figure it out, you pause me and you figure it out. Let's do this together. What is the oxidation number of zinc? Zinc, it's the elemental form by itself, has no charge. So the oxidation number is 0. Now, zinc over here now is forming an ionic compound. When you form an ionic compound, something has to lose, something has to gain. Now you have charges, which is the same as oxidation number. So by itself, 0. Now that you're an ionic compound, now you have a charge. So what's the charge of zinc? The 2 comes from the zinc. Zinc is plus 2. So I went from 0 to plus 2. 0 to plus 2. What happened to you? You became more positive. When you become more positive, you are oxidation. So what this one is oxidation. Okay? Now, let's do it here. Let's do on this part first. This is easier. What is H2? What's the charge oxidation number of H2? Is 0, diatomic molecule. That's how it exists in nature. Now, let me come over here. Okay, so what's the oxidation number of hydrogen? Remember what we said? We said when you have when you have a compound, you have to go by charges. You know, Cl is -1, hydrogen is plus 1, right? Hydrogen is always +1, except H2, that's how it exists in nature. So, again, exists in nature, that's the elemental form. The charge is 0. Here, Cl is minus, H is plus, right? I have ionic compound, so plus going to 0. It became more negative. When you become more negative, you are reduction. And also keep in mind, if you end up having both reduction or both oxidation, that's not good. One has to reduce, one has to oxidize. One loses, the other one has to gain that. Beautiful. Last one. What is my reducing agent? What's my oxidizing agent? Do the opposite, right? If I do oxidation, that means this one is my reducing agent. And then that means this one is my oxidizing agent. And the agent, they always have to be on a left-hand side. They always have to be the reactant. The reactant, one is reducing agent, one is oxidizing agent. Beautiful. Now, some of you guys will go, okay, so zinc was oxidized and hydrogen was reduced. What the heck is going on with Cl? Well, Cl is not doing anything. Cl is a spectator. The charge of Cl doesn't change. And I'm going to prove that to you. And to prove this to yourself, you can sometimes write a net ionic equation for this. If I do that, So zinc solid is by itself. Hydrochloric acid is a strong acid, so it would break up in water into H plus and Cl minus. Zinc chloride also would break up in water. It would break up into zinc plus 2 and 2Cl minus. This was the last chapter. Okay. And then, of course, H2 gas, that would not break up. I should have moved that. That just stays together, is the elemental form. But zinc chloride ionic compound would dissolve in water, break up. Ionic compound, a strong acid, would break up in water. Now, what are the spectator ions? Which one the one that I can cancel out? Cl is a spectator ion. It looks exactly the same on both sides. So the Cl has the same charge, looks exactly the same on both sides. It's not really doing anything. It's a spectator. It's not really making any difference in my redox reaction. Now, can I cancel out the zinc? You cannot, because this zinc over here is zinc solid. Now, the zinc over here is dissolved in water, so is AQ. You cannot cancel out if they're not exactly the same. They have to be exactly the same to be able to do it. This is solid, this is an ion. We cannot cancel it out. So far, so good. So this still doesn't do anything. All right, ready for our next problem. Here's our next problem. What I want you to do before we balance the equation, I want you to pause me and then figure out what's been oxidized, what's been reduced, oxidizing agent, and reducing agent. Let's do that. Okay. Now, over here, Cl2 is a diatomic molecule. That means that's how it exists in nature. That's the elemental form. So the charge is 0. Beautiful. Okay. Now, over here, what happens to the Cl? ClO3 minus. That's the polyatomic ion. Those are two nonmetals together. So this is a covalent compound. So I need to figure out, using the rules, you need to figure out what is the oxidation number. So I'm going to go ClO3 minus. I give you a charge, so put the charge. The entire thing is equal -1. You know oxygen is always -2. That never changes. So -2 times 3 is -6. So what Cl is going to be +5. Again, two nonmetals together is a covalent compound. It's not a balance of charges anymore. I can need to do the rules to figure out what is the oxidation number of Cl. Oxygen is always -2, but Cl, I need to figure it out. So, we went from 0 to +5. What happened? That got oxidized because it became more positive. So far, so good? Okay. Now, let's come over here. What's the charge on Mn? +2. If I give you a charge, you got to use that charge, right? I give you a charge, that's the oxidation number. Now, how about over here? MnO2. You can also use the rule to figure it out. The entire thing equals what? 0. Why? Neutral compound. I don't give you any charge. Don't get fancy on me. Don't try to put a charge. Now, oxygen is always -2 times 2. It would be -4. So what would be the charge of Mn? +4. So here's +4 going to +2. What happened? It got more negative, right? So that means what am I? That means I am reduction. Beautiful. Now, shout the answer. What is a reducing agent? The reducing agents have to be on the left-hand side. This one got oxidized, it has to be a reducing agent. This one got reduced, it has to be an oxidizing agent. Okay, beautiful. Now here's what I want you to do. I want you to rewrite this equation, and I want you to balance this redox equation. You know the rules for the balancing the redox. Okay, pause me and balance this redox reaction. Okay. So here's again the balancing redox reaction. These are the rules. Hopefully you have them down by now. Rule number 1, write 2 half reactions. So what I'm going to do, I'm going to write 2 half reaction. And that is my Cl2 is going to ClO3 minus, and MnO2 is going to Mn +2. Rule number 1, balance everything except oxygen, hydrogen, and charges. I have 2 Cl here. I have 1 Cl here. So what I have to do, I have to put a 2 over here. 1 Mn, 1 Mn, I'm good. Then balance the oxygen by adding water to the side that does not have enough water. How many oxygen here I have? 0. How many here? Be careful, be careful. 2 times 3, because you have 2 ClO3 minus now. So that would be 6. 6 and none over here. So what I would do, I would add a 6 H2O on this side. Okay. How about down here? How many oxygen do I have? I have 2 oxygen. I have no oxygen. So what I would do, I would add 2 H2O to this side. Then you balance the hydrogen by adding H+. Okay? Now, on this side, how many hydrogen do you have? Be careful, be careful. You have 12 hydrogen. Beautiful. On this side, I have no hydrogen. So 12, no hydrogen. So I would have to add it to this side. I would add 12 H+. So you add H+ to the side that has no hydrogen. Okay. Now, over here, how many hydrogen? Nothing. How about over here? I have 4 hydrogen. So what I would add 4 hydrogen over here. So we balance the oxygen, the hydrogen. Last thing, you're going to balance the charges by adding electrons. And again, because electrons are negative, we add it to the more positive side. What's the charge on this side? Neutral compound, neutral compound. So this side has no charge. What's the charge on this way side? Pay attention to this. I have 2 ClO3 minus and 12 H+. So I have 2 minus and 12 pluses. So together, how many that would be? 10. That would be plus 10. So this side is my more positive side. Now, how many electrons do I add to balance it out? Hopefully you're yelling that 10 electrons, because then I have 10 minus 10. This would be 0. It matches up with this one. We're trying to match up the number of charges. All right, let's come over here. What's the charge on here? 4 pluses. This is neutral. It has no charge. Let it go. This would be neutral. This would be 4 plus 4. Now, how about on this side? 1 plus 2, and this is 0. 1 plus 2, I have 1 Mn plus 2, so 1 plus 2, and this is 0. So the charge on this side would be plus 2. Now, this side is a more positive side. But how many electrons would I add? I would add 2 electrons, because then again, 4 minus 2, this would be 2. It matches up the 2 over here. Beautiful. Okay, last thing. If I lose $10, you gain $10. If I lose $20, you gain $20. Remember that. These two have to be exactly the same number. This one lost 10. This one gained 2. You cannot have that. These two have to be the same. So you're going to multiply by a factor to make sure they're the same. So the easiest way to do this is if I multiply the bottom one by 5. In that case, 5 times 2 is 10. 10 and 10, they match up. All right. Now, last thing to do, we are going to recombine everything. Add up all the reactant together and add up all the product together. Just don't forget to multiply this out. So, do it with me. Then that means I have 6 H2O plus Cl2. I'm going to come down there. Then I'm going to come down here. Don't forget. Then I have 10 electrons plus 20 H plus, because I did 5 times 4. Then I have 5 MnO2. I'm going to go to the product side now. I have 2 ClO3 minus plus 12 H plus 10 electrons plus Mn. Let me see. Plus Mn plus 2. And then I have 5 Mn plus 2. Don't forget. Plus 10 H2O. Okay, I almost forgot to multiply it out. No, I did that on purpose, so you know what not to do. All right, now the very last thing, is there anything I can cancel out? We talked about this. As when you get to this point, you better be able to cancel out the electrons. If not, you're in a lot of trouble. Okay, so that's good. Now, is there anything else I can cancel out here? There actually is. I have 6 water here. I have 10 water here. So I can say minus 6 H2O. So then the H2O will go away. And then minus 6 H2O. So then what I would end up here, I would end up with 4 H2O. So far, so good? Okay. Is there anything else? Do you see anything else? Yeah. Over here, I have 20H plus. Over here, I have 12H plus. So minus 12H plus minus 12H plus. If I do that, this will go away. And this will become 8H plus. Sometimes I have to think about my math. Okay, that's it. So sometimes you have to be careful. You might be able to cancel out the H plus in water. And then electrons you should definitely be able to cancel out. Beautiful. Now let's double check. RR rule. If you add electrons to the right hand side, that's a reducing agent. That's a way to check yourself, right? So if you add electrons to the right side, if you add electron to the right side, that's a reducing agent. Okay, that's what we call it, the RR rule. You add electron to the right, that's a reducing agent. That's a way to double check yourself. Here I added electron to the left. Here I added electron to the right. Again, agent always have to be on the reactant side. I know I keep repeating. Please remember that. So these two are the agent. I add electrons to the right. That means this guy over here is my reducing agent. If this is my reducing agent, the other one automatically become oxidizing agent. Now let's see. This part always freaks me out if it doesn't match. This matches what we talked about. Does it? Does it? Yes, it does. Look at that. It's a good way to confirm your answer. Not a bad way to confirm your answer. Okay. Let's do one more practice problem, okay? I know you're probably tired of me at this point, but let's do one more. One last one. More practice is always better. C2O4 minus 2 plus Pb plus 4 goes to CO2 plus Pb. Okay, first of all, figure out what's been oxidized, what's been reduced, oxidizing agent, and reducing agent. You ready? Okay. So, Pb over here was the charge, plus 4. When I give you a charge, that's the charge it has. Over here, Pb has no charge. It's by itself. It's the elemental form. So the charge is 0. So plus 4 to 0, that means I got reduction because it got more negative. Now let's come over here. Again, oxygen never changes. We know that. It's always minus 2. We need to look at carbon and what's going on with carbon. Well, what I have here, I have a covalent compound and I have a covalent compound. So I need to do the rule to figure out the oxidation number. So I have C2O4 minus 2. The entire thing equals minus 2 because I give you a charge. Now I know oxygen is always minus 2 times 4 is minus 8. And then I have C2. So C2 would equal plus 6. Carbon would equal plus 3. So my carbon over here has an oxidation number plus 3. Again, it's a covalent compound, 2 nonmetals together. I have to do the rule to figure it out. I don't care about oxygen, it's always the same. The carbon is the one that I'm looking for. Oxygen is always minus 2. Now CO2, okay, the entire thing is equal 0. The entire thing is equal 0. There's no charge. This one has a charge, this one has no charge. I know oxygen is always minus 2 times 2 is minus 4. So carbon would be plus 4 over here. So carbon went from plus 3 to plus 4. It got more positive, so that is oxidation. Again, remember, one has to be oxidized, one has to be reduced. If you get the same kind, That's not good. All right, what's the oxidizing agent? What's the reducing agent? Hopefully you got that down by now. This one is reducing agent. This one is an oxidizing agent, because if you got oxidized, you're reducing agent. If you got reduced, you're oxidizing agent. Is the opposite. Okay. So, nice job. Now you know what's coming, right? What I'm going to ask you to do right now, this is the last thing, promise you. I want to ask you to rewrite that equation, and I want you to balance the redox. I want you to balance the redox. Okay, to balance the redox, again, don't forget to pause me and do it on your own first. You're going to write down 2 half reaction. Okay, we balance everything but oxygen and hydrogen. I have 2 carbon, I have 1 carbon. 2 carbon, 1 carbon. So I have to add a 2 over here. Then I end up having 2 carbon, 2 carbon. 1 PB, 1 PB. I'm okay. Again, don't worry about charges. We do not worry about charges, oxygen, or hydrogen. Then balance the oxygen by adding water. How many oxygen do I have here? This is a tricky question. Now that I'm thinking about it, like, wow, this is a good question I put out there. How many? You have 4 oxygen, don't you? How many oxygen do you have here? Yeah, you also have 4 oxygen, so this is okay. The oxygen are actually balanced. Tricky question, yeah, sometimes I like my own questions. So, both are 4 oxygen. Again, if you didn't follow that, 4 oxygen, 2 times 2 is also 4 oxygen, so I'm good. Now over here, there's no oxygen, there's no hydrogen here, so I don't have to worry about hydrogen or oxygen. Now let's go to charges. What's the charge on this side? -2, because I have 1 -2. This side, this is a neutral compound. There is no charge. So I'm going to balance the charges by adding to the more positive side, which is this side. How many do I add? I add 2, because then 0 minus 2 ends up being -2. It matches this side over here. Now over here, this side is +4, this side is 0. So this is my more positive side. How many do I add? I add 4. If I add 4, then it will be 0, 0 matches that. Okay, so far so good. Now last thing, this guy lost 2 electrons, this guy gained 4 electrons. That cannot be happening. These two have to be exactly the same one. How do I make it? How about if I multiply this by 2? If I do that, this would be 4. It would match this one. Last thing to do is combine all the reactant together and combine all the product together. Don't forget to multiply this out. If I do that, I get 2C2O4 minus 2 plus, when we come down there, 4 electron plus Pb plus 4. Let's go to the product. 4 CO2 plus 4 electrons plus Pb. Is there anything I can cancel out? Electrons for sure. All right. Does the RR rule apply here? Does that make sense? If I add electrons to the right, this is my reducing agent, okay? Which means this guy is my oxidizing agent. So C2O4 minus 2 is my reducing agent. Does that match up what we had before? Oh yeah. Oh yeah. Look at that. Okay. That matched up. Not too bad, right? All right. So remember, for redox, the charges have to change. That's how you know if you have a redox reaction. Okay, beautiful. Nice job.